In this video, we're going to begin to see some terminology related to differential equations. And at the end, we'll start to see how we might be able to solve differential equations. So first, what is a differential equation? Right? A differential equation is an equation containing the derivatives of one or more functions or dependent variables with respect to one or more independent variables. And here we have some notation. You should all be familiar with Leibniz notation. Then there's the prime notation, which was used by Newton. And then for partial derivatives, which you would have seen in a Calculus 3 course, we have those last two. Partial derivative notation, called partial notation. Also, subscript notation is generally used for partial derivatives as well. So there are two types of differential equations related there, right? There's ordinary differential equations, or ODEs, and that has only one independent variable. And then there is partial differential equations, or PDEs, which has two or more independent variables. And again, in the notation up there, the first two, Leibniz and prime notation up there, are representing ODEs, and those second two, partial notation, subscript notation, are representing examples of PDEs. Okay, so let's look at this first example here. We want to just determine the type of the following differential equation. Do we have an ODE or do we have a PDE? So I'm going to call this 1, 2, 3, 4, 5, and 6. And for number 1, what is this? Is this an ODE or a PDE? Notice that we just have one independent variable t here, even though we have a function of t over here, and then we have our dependent variable x. We only have one independent variable here, t, so this is an ODE. 2. Again, we have x and t as our variables, but again, only one independent variable, t here, so this is an ODE. 3, same thing. We have only one independent variable here, so we have an ODE. As in, we are only taking the derivative with respect to one variable here, t. So there's an ODE. Number 4. Hey, we're using our partial notation. And we notice there are two independent variables here, t and s. T and s. So this is a PDE, because we are taking derivatives with respect to two different variables there. Number 5. Again, we notice there are two independent variables here, s and t, so this is a PDE. Oops. I will erase that. Maybe. There we go. So we have a PDE. And then in 6, again, we have two independent variables, s and t, so PDE. All right. So let's move on to our next example now. And that is to discuss the order of the differential equation. And the order of differential equation is the order of the highest derivative in the equation. So if we look back up at the examples previously, and now we're going to do example 2 here, let's go with the same numbering system that we had last time. Then 1 we look at the highest order of the derivative, well, we have dx dt, so that is a first order. Really, we should just say first order. For number 2, we have a d squared x dt squared. So that notation means the second derivative of x with respect to t. So we have a second derivative, i.e. this is a second order differential equation. Number 3, so at the top right there, again, we have first order. Then we have, for number 4, we have a second order partial differential equation here. For number 5, again, we have second order partial. And number 6, we have a first order partial. All right. And so that is all of the examples for what the order is of those particular differential equations. After this, we will start to discuss the linearity. So let's go look at that. But before we talk about linearity, one quick note here. In this course, we're going to be focusing primarily on ordinary differential equations. So a single independent variable. And in general, we'll also have a single dependent variable. Okay. Oh yeah, so sorry, getting used to doing this on the tablet. So we have linearity here. The nth order linear ordinary differential equation has the following form. And that's this particular equation here. Notice that on one side, we're going to write out some function of the independent variable t. And then we have on the left side, we have a linear expression in terms of our independent variable t and this dependent variable x. Now, this is linear because nothing is happening to the x except for we're multiplying by some expression of t each time. So each of these terms of x here, so we see an x here, we see a derivative of an x, we see a derivative, an n minus first derivative of an x, and we see an nth derivative of an x. Nothing is happening to those x's or the derivatives of x's, except for it is multiplied by functions of t. So we get some functions of t here. And as long as that is the case, we have a nth order because our highest derivative is n. And it is linear because we don't have anything happen to these derivatives of x, except for, again, multiplied by these expressions or functions of t. And then it is an ordinary differential equation because we have our dependent variable x and just one independent variable t. All right. So let's erase these markings real quick, and then we're going to move on to page 2. And in particular, we have the general first order linear ordinary differential equation, which will look like this. A sub 1 of t times x prime plus a naught of t times x is equal to g of t. And then the second order linear differential equation is the same as the first order, except we add in this extra term over here on the left. So we get our second order, so a sub 2 times t, so that is just some function of t, times the second derivative of x. Okay. So let's discuss real quick some